What's up, my mathlete? That's right, Mr. Muscarella coming at you. We're going to take a look at writing equations of lines from graphs. So we're going to take a look at some graphs and then calculate the slopes and use some points that we can tell from a graph and actually come up with the equation of a line in multiple forms, of course. So let's go. So we're going to have to find the slope-intercept form, standard form, and the point-slope form for every single line. And the order is not going to be particular here, but I want you to just look for some patterns. All right, so first thing we got to do is come up with some points on this line, right? And I want to look for lattice points. So that means they crisscross at a whole number and an integer in each spot. So like this would be a good spot, a good point to use. But if I were to say maybe pick this guy right here, like I don't know the exact coordinates of that, so I'm not just crazy. So we're going to pick a couple of points on this line and see what patterns we can come up with. And then if I keep going, it looks like there's another lattice point. And so let's kind of see what we have so far. And if I were to go make a step, if you will. So we're going to do kind of that rise run thing. And if I look at this, I go over one, down one, two, three. I go over one, down one, two, three. So those step sizes look the same. If I were to go over one and down one, two, three, it would cross the y-axis. So I've got all these points on here. Now, what's really cool about that value that we just found, the 0, negative 4 point, or 0, negative 5, sorry, my bad. When you take a look at that, right, 0, negative 5, that is actually the y coordinate. So it's really cool because we actually came up with when we look at that y coordinate, that's the y-intercept. So we can actually start this thing off in slope-intercept form. So slope-intercept form, well, we know what it is, and we know that the slope-intercept, the b value is negative 5, but I got to figure out where the slope is first. Now, all of those stairs, they all have the same kind of step height. And if I count up 3 over 1, up 3 over 1 every single time, up 3 over 1, I got a 1 there, then I go up 3. But be careful because the slope on this one is negative. So my slope is negative on this one because of the slant of the line. So my slope would be negative 3. So when I were to write this equation in a line, I would just write y equals negative 3x, right? Because that would be my slope. And then my y-intercept, we found that to be minus 5. That's not so bad. We're done. Now from here, I can go right into standard form by just taking that negative 3x and moving that over to the other side. So my standard form value, standard form equation, pretty straightforward. We take that 3x, we move it over, we'll get 3x plus y equals negative 5. And if I look at that, remember, don't forget standard form, we always got to analyze this term here. That ax term is going to be positive in a whole number. In this case, it is. Boom, diggity, we done with standard form. So that's cool. So we're rolling here. We got slope-intercept form and we got standard form. Now the last one, there could be some various answers on this one, right? Because there are multiple points that we've come up with on here. So let me kind of get this guy out of the way, get all of these out of here, and then we'll take a look at some of the coordinates that we could use for possibilities for, we'll just abbreviate point slope, PS. So here's one value. Say I use the point that's all the way up at the top, this negative 3, 4. If I use that, then the equation that we would come up with off of there would be y minus 4 equals, and I already found my slope, right? We found our slope to be negative 3, so we'd have negative 3 times x. And you see, we got to be careful because that minus 3 is going to go to plus 3. So that's if we use that. I'm going to call this point A up here. All right, so if we use point A, that would be the equation that we come up with. Now, if we wanted to use another point, say, and we're going to call this point B. So say I use a point negative 2 and then 1. So if I use that as my xy coordinates for that, then in this case, I'd have y minus 1 equals, and then still negative 3, but then this time I'd have x plus 2. So this, if I use that point, point B, then I would have a little bit different equation. And then lastly here, if we use point C, right? So say I use a point negative 1, negative 2, and I call that point C, then in this case, we would have the equation y minus negative 2, which changes to y plus 2. And then I'd still have negative 3 for my slope, but now I would have x plus 1. And I want you to notice kind of a little bit of a pattern in here too, because we found our slope to be negative 3. And if you look at these values here, so I'm going to highlight them in yellow, If I go from -4 to -1, that difference is going to be the same difference that's between -1 and -2. So that's the rise value. When you look at rise run, that's going to be the rise value. Now my run value was 1 because we went up 3, but our run value, we go over 1. So notice again here, if I look at the x coordinates right there, I have +3, +2, +1. All of those have a difference of 1. Isn't that cool? Little patterns there. So that's how you do that, man. Straightforward stuff. Look at the information, see if you can pick up some patterns, and then just roll with it. But for point slope form, you're going to have multiple possibilities for that, depending on which version or which point you pick from the graph, because you got your options. The graph is made up of infinitely many points when you have a linear function. All right, so cool. So that's it, example 1, man. Hope you guys enjoyed this one. Come on back and check out example number 2, and I'll catch you later. Peace.